We have a new components. Ayan na naman bagay yan. We have this Zener Diode. Ayan naman ang gagawin mo diyan. We're going to make a voltage regulator using a Zener Diode. We now connected the Zener Diode together with the resistor. And the Zener Diode is connected to the tester to monitor the voltage. We have the variable power supply. Adjusting the voltage to 3 volts, 0.7 volts. Why is it that the voltage at the Zener Diode is 0.7 volts? Because our Zener Diode is connected in forward bias, so it serves as a regular diode. So the Zener Diode now is connected in reverse bias with the circuit in series with the resistor. Let us now adjust the voltage. Initially we have 0.013 volts DC. Adjusting the voltage to 2 volts, the same, and 3. Okay, 3 volts. Still 2.7 volts. 4 volts. 6 volts. 2.9. 7, 3.1. 10, 3.3. 12 volts, 3.4. So our Zener Diode is regulating the voltage at around 3.4 or 3.3. Even with the supply of 12.32, the output is 3.4. So it means it keeps the voltage at the Zener Diode to be regulated 3.4. At 9 volts, it's around 3.2. Because our Zener Diode has a voltage rating of 3. I think it's 3.3. So as we keep on decreasing the voltage at 5 volts, Zener Diode now in 2.9 volts or approximately 3 volts. Increasing the voltage up to 12 volts. 3.4 volts. How about 13? 3.4. 15, 3.5. So you can see here that the Zener Diode is keep on regulating the voltage at around 3 volts, 3.4, 5, or 3 at that number. Decreasing again the voltage. At around 3 volts, 2.6 volts. There is a tolerance with the Zener Diode. In our first test, we are connecting the Zener Diode in a forward bias condition. We are using a 1N4728 3.3 volts Zener diode. So we're using a variable voltage supply from 0 to 12 volts. And then in series with the Zener diode is the 1K. In order not to damage the Zener diode. So the current flows in a conventional direction. So we connected the tester here. So in parallel with Zener diode. And as we keep on adjusting the voltage, what is the voltage across the Zener diode? It is 0.7 volts. The diode, Zener diode, function as a regular diode when connected in a forward bias condition. Even this diode is rated at 3.3 volts, still it functions as a normal diode with a voltage drop or forward voltage of 0.7 volts. While adjusting the supply from 0 to 12 volts, still the voltage drop across the diode is 0.7 volts, just like an ordinary diode. And what happened to the remaining voltage? It goes to the absorbed by the resistor 1K. That's why we have, if we are using 12 volts, so 0.7, 12 volts minus 0.7, the voltage drop across this resistor is 11.3 volts, and the 0.7 volts will drop into the Zener diode, always at 0.7 volts. While if we're going to connect the diode in a reverse bias, now it will now serve as a voltage regulator. As we keep on increasing the voltage from 0 to 12, it will regulate according to its voltage rating. So our voltage rating of the diode is 3.3 volts. The supply must be greater than 3.3 volts in order to regulate the diode at 3.3 volts. It keeps on making this voltage of the diode to be in a 3.3 volts. So we connected the tester across the diode. So at around 3 volts, if the supply is 3 volts, diode keep on regulating the voltage across it at around 2.9 up to 3.5 volts or 4 volts. If we keep on increasing the supply, it will regulate around 3 to 3.5 volts. That is the voltage rating of the diode. So if we're going to connect a load here in parallel, since voltage in parallel is equal, so whatever the voltage at the diode is the same as the voltage of the load.